Okay, so please check in your book there. There is some important information maybe you have to highlight there. It says that given that 3 sine square x minus 8 cos x minus 7 is equal to 0, show that for real values of x, cos of x is equal to negative 2 over 3. Most of us could do that, but I'm just going to put it up there again because in order for us to do part B, because of that, for real values, because the question says, hence, from what you have now deduced from the first part of the question, now solve the equation. But then there are some general solutions there because you have got some, it's not just an angle on its own, there's something being subtracted. The moment you have got something inside there, like a 3x or 3 theta, you must think of general solutions, even stuff like that. Okay, so quickly if we do this, we know that this becomes 1 minus cos square x minus 8 cos x minus 7. You with me so far? Okay. So this becomes a quadratic as well. And also, one of the answers will be rejected because they say we should show cos x equals to negative 2 over 3. So there is going to be a possibility that what answer will be equal to. You can actually solve this, right? Even if you don't know how to show this. You follow what I'm saying? You can find a acute basic angle and then you work from there. Because part B contains some stuff inside the theta, you're going to look for the general solution so that you can find the other solutions. So anyway, so I'm going to move the 3, so it's going to be minus 7 plus 3. So that gives you minus 3 cos square x minus 8 cos x minus 4 equals to 0. So you're going to divide by negative 1. So you're going to have cos square x 3 plus 8 cos x plus 4 equals to 0. You say let cos x equals to some letter k, for example. So that gives you 3k squared plus 8k plus 4 equals to 0. If you want to solve this particular equation, I just go ahead and I do this because I'm not even going to waste my time trying to find those two numbers. You understand? But if you have the calculator, I think you get 16 here. So that means in our quadratic equation formula, we've got the value of b, which is minus 8 plus. Now remember, it's going to be under the root sign, which means you're going to have an answer of plus minus 4. Right, so plus 4 is going to be over 2, and 2 times 3, or x is going to be minus 8 minus 4 on 6. 6 comes from 2 times 3. So x is equal to negative 2. Well, this is going to be simplifying to negative 2 over 3. Now, put your value of cos x back. So cos x is equal to negative 2 over 3. One we're required to show. The other one is cos x is equal to negative 2. And you are going to reject this one because you can't find a negative for it. Right, so we have shown that is 5. Now, part B says, hence, you are supposed to solve the equation. What is that equation? It has got some stuff in there. So it's 3 sin squared, but you have got theta plus 70, am I right?
Yes, sir.
Minus 8 cos of theta plus 70 minus 7 equals to 0. But you already have this. So you are going to take this answer and you're going to, you're going to use the answer here in order for you to find that. So I can also say let u equals to theta plus 70. Okay? So at first you need to be able to find that reference angle. Okay? Just want to check the domain. They are saying the domain here is from 0. Is it 200? 180 inclusive. So you can set your calculator in degree mode. Please go ahead and do that. Okay? Okay, so before I continue here, let's work with that and find our acute basic angle. Is that fine? With the value that we can calculate. So we also know from here, we are not going to look at these two last quadrants. We are interested in the first quadrant and interested in the second quadrant. Okay? From our given domain here. Alright. So cos of x equals to, now this x, we're going to replace this whole x with a u. Because I'm going to say let u equal to theta plus 17. You understand? Good. So cos u equals to, or just u equals to, the inverse cos of 2 over 3. Don't put a minus when we are looking for the reference angle. Right. So what is the reference angle equal to? Please give me that answer in degrees. Maybe give me to 3 decimal places. Okay, let's go up to there, no problem. Okay, so that's what we have for our u. Now, this, you don't agree? Put 8.1896. There's a 8 after that. Are you happy now if I do that? 3 dots. So you got a bit worried, is it not? Okay. Alright. Say that 9. Okay. So according to our given domain here, we are not dealing with that. We are looking where cos is actually negative. So we are not going to consider this part as well. So we are going to work with a reference, our k, some angle that involves this stuff here is going to be 180 minus whatever that particular angle would be. Alright, so in the second quadrant, you're going to have 180. So let me first bring, I can say u equals to, okay? But since we are now finding that general solution, let's bring the, where did I put it? Theta plus 70 equals to 180 minus this stuff here, which is 48.1 blah blah. But our cosine, there is going to be a revolution, okay? Because we have got something here, so something implies that we have to look at that revolution. So, what do you get when you subtract that from that? Give me that theta, the general solution in terms of theta.
131.
So you get theta equals to 131.
0.81
degrees plus 368. For you're subtracting, you did subtract this from each other, and then you subtracted the 7. What's that? In fact, let us do something first. Let us first find our particular angle. Maybe we can call it a k. Alright, so that we can start solving it. That 131.8. Let's only bring the domain towards the end. Because we are told we have to find all real values. In which other quadrant is cosine negative? I'm going to use the general formula only at the end. I want now to find two solutions that will satisfy this condition for the general values. It says, if you look at the question says, for real values of x, there's no domain given, so let's go all the way up to 360 to find those two quadrants, and then we're going to put the general formula afterwards, okay? So it will be 180 plus theta, that will be the third quadrant. Just add 180 here. Don't forget to subtract the 270. 61 point? Everything? Everything?
The first one.
Yeah. Hundred and? No. Okay. Let's bring it here for another solution. Let's not confuse each other. Okay? Alright, so this will be our general solution in the second quadrant. Okay, you do 181 48.1 and then you subtract 70. You got this. You subtracted the 70 only. That's 110. Okay. So 61.1. It's not what I'm looking for. It's not what I'm looking for. I'm just looking for the 131.8 first alone on its own. You get it? When we are here, when you subtract 180 minus theta, okay, minus this 48, what do you get? Before we look at our general solution, when we are here, 180 minus our theta, good. I want that particular value. Right? In the second, it's going to be in the second. 180 in the second. 180 minus 48.18968. What do we get?
Exactly.
Give me the real numbers, please. 81 something, eh? 81. It's not so. What would it be in the third quadrant?
Just the big one.
8. 48 to that.
88.9.
What is it? How is it 400? 200 and? Okay, so this would be our solutions for that. But we are not looking for u, so we are looking for theta. So now according to our domain here, only consider between 0 to 180. The angles that we are going to look for should be an angle that fit within that domain. So if you take theta plus 70 degrees equals to 131.8 plus 360 n, where n is the resolution that it makes, okay? And also theta plus 70 equals to 200 n, what is it? 28.18 blah 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 plus 360 n. So we're going to look for possible answers that we're going to get. Right. So first of all, if n is equal to 0, there's no point in making n 1 because that is going to be already above our domain because our domain is only up to 180. So if that is 0, then 131.8, then you subtract 70 from that. Okay? And that gives us, what is the solution? 61.8, which is within our domain. Okay? Now let's also use here when n equals to 0, also in this condition. What do you get for theta? So you get that 228.18 blah blah blah.
158.
Then you subtract 70 from it. 158.2, which is also within our range of our domain. Okay. You can stop.